Hello students, welcome to the next lecture on the CSR UGC NET. Today we will discuss about the linear algebra. This is the part 2 where we discuss all those questions from the year 11 to 23. As usual, we will describe all those questions with the help of shortcut quick. What you can do, you can simply join my WhatsApp group and subscribe my YouTube channel Dr. Harish Garg. What you will be found on my YouTube channel, there is a playlist of the CSIR NET where you can find the PY question of the real analysis from the year 11 to 23. Complex analysis, Markov chain, linear algebra. This is the part 1 where you have discussed the June 11 papers, 11 to 23 complete papers. You can also find the PY question of the partial differential equation, ordinary differential equations, as well as the integral equation, calculus of variation. All are from the year 11 to 23. So in this lecture we will see more than 70 plus questions related to the year 11 to 23. After this video we will describe the next video related to the part C. So let's start with this video. This is the question from the year December 2011. So clearly say this is my 6x6 matrix. So it is very difficult if you try to expand this matrix in terms of here. It will take a minimum of the 5 minutes in the examination. What you can do, you can convert this matrix into the two matrix, addition of the two matrix. So if you look about that, the first value you can see this, the diagonal is my 1. So I can consider this is my diagonal as a 1. This is 6 elements, rest I consider as 0. If you look about another way, you can see this is another diagonal, but it is on the opposite side. So 3, 4, 5, 6 all are my 0. Now how you can find the determinant? So we all know we can apply the eigenvalue property. So what is the eigenvalue of this matrix? So 1, 1, 1 up to the 6th time. What is the eigenvalue of this? So always remember this shortcut tricks. Whenever there is a diagonal values of say alpha and alpha, the eigenvalues are always be minus alpha plus alpha, that is of the opposite sign. Here how many values are there? There are 6 values, so the eigenvalues are 3 are negative and 3 are my positive. So what is the eigenvalue of this is the plus a plus b. If I call this is a, this is b. So what is the eigenvalue of the a plus b? That is the eigenvalue of this matrix are minus 1, minus 1, minus 1, 3, 3, 3. And product of the eigenvalue is nothing but my determinant of that. So what is the determinant? Minus 27 is the right answer. So you can see within a 1 minute you can solve this question in a simple way. Okay, look at the next one. This is my n cross n matrix. So as I discussed you in previously, you can choose the value of the n as per your own convenience. So this is my greater than equal to 3. So I can consider this as my 3 cross 3. Then the elements are written in the form of the bi, bj. What is that? They are the distinct real numbers. So what is that? This is my b1, b2, b3, because I consider n is my 3. And they are distinct. So I can consider this as a 1, this as a 0, this is my minus 1 for the sake of simplicity. So what is the alpha 1, 1? This is b1 square minus b1 square, it's a 0. So diagonal entries are my 0. What is that? Alpha 1, 2 is a b1 square minus b2 square. So b1 square minus b2 square, 1. Next is 1, 3, 0. It's a 1, 2. So it's a 2, 1, minus 1. It's a 2, 2, it's a 2, 3. Is a minus 1. Is a 3, 1, alpha 3, 1. So it's my 0. Alpha 3, 2, it's my 1. And so now you can find the determinant of this. What is the determinant of this? So it's a 0 minus 0. 0 is the right answer of this problem. So you can see within a very fraction of second you can solve the problem. Easy man. Now how you can find the determinants? Again you can see there is a no x, y, z values are there. You can choose any of the value of the x, you can choose any value of the y, any value of the z. But make sure if you are thinking to choose all are 1, then what will be the option? The first option is 0, 0, 0 and 0. Then you are unable to compute the difference between them. So what you can do that? You can choose the distinct values. Again I can choose 0, 1, minus 1. Because they are the distinct and you can see none of the values is my 0. So what is that? It's 1, 1, 1. It is my 2. It's my 1. It's my 0. What is 1 plus 1 plus 1? 3. It is 1. It is 1 minus 1, 0. It's a plus 1. Now clearly you can easily find the determinant of this matrix. So it is 1 minus 0, minus of 2, 1 minus 1, plus of 3, 1, 0, minus 1. So 1 minus 3 is my minus of 2. Now look at the option. What is the z minus y? It's my minus 1. Z minus x, minus of 2. Y minus x, minus 1. So product is my minus 2 is the right answer. You can check also for the others. What is the x minus y? Plus 1. X minus z, plus of 2. Y minus z plus 1, which is not equal to minus 2. Cancel out. This number can never be negative because it's a square. This number can never be negative. So this option is also cancelled. X square 1 minus 0 1. Y square minus z square minus 1. Z square minus of 2. So product is my plus of 2. So the right answer is only my first is the correct answer. Now again you can think about the determinant of the permutation of the n cross n. So I can choose n is my 2 firstly. So it is my 2 cross 2. These are the values. So what is the determinant of this? So we can see eigenvalues are my minus 1 and plus 1. These are my eigenvalue, or otherwise you can find the determinant of this matrix. It is clearly say it's a minus 1. So this option cancel. When n is equal to 2, this option cancel. Now, and when n is equal to 2, it's a 1. So both options correct. If I take n is 3, so 0, 0, 1, 1, 1. So rest values are my 0. So what is the eigenvalues of this? You can see there are 3. So 1 is there and here. Fine. So what is the product of them? Sorry, it's a minus 1, plus 1, plus 1. This for the pair, or you can find the determinant. So you can see it's a plus 1, 0, minus 1. So product will be minus 1 because this is the odd number. So again these are the correct option. N is my 3. If you consider n is my 1, it's a 1 cross 1. That is the value is my 1. N is my 1. So this is half. So greatest integer is my 0. Anything power 0 is 1. This option is cancelled. Okay, look at this another question. This is the 5 cross 4 such that A x transpose is given to be here. This is my solution space. What is that? This is 1 plus 2s, 2 plus 3s, 3 plus 4s and 4 plus 5s. Then your target is to find the rank of the A. So definitely we all know rank of A is always be less than of the number of the rows, number of the columns. So it will be less than equal to 4. So all options are satisfied. I can write this as of this nature. I can take S as a common, 2, 3, 4 and 5. So what is that? This is the linear combination of the vectors A plus B of S. Then whenever there is a form of the A plus BS, this will give you the nullity. This will give you the nullity. So what is that? So you can see if I apply the rank nullity theorem, nullity of A is my n. N is my number of the column vectors. Column is my 4. So what is the nullity? There is only, what is the dimension of the nullity is 1. So this value is my 1. So rank value will be my 3 is the right. Okay, look at this another question. So what you can do, again if you are thinking about, you can expand like of this yr minus qz, it will take you a lot of time in the examinations. So look at that. Is there any value given to you a, b, x, y, z? Any restriction is given to you? No. So what you can do, you can choose the value of the a, b, c as per your own convenience, but make sure d1 can never be 0, because if d1 is 0, according to this option, d2 will also be a 0. So then you are unable to distinguish between them. So I can choose the value like of this manner. What is that? The determinant is a 1, which is non-zero. Fine. So what is the meaning of that? I can consider the value of the a, y and r as a 1, rest all are 0. So what is my b, d2? A is my 1, x is my 0, y is my 1, z is 0, b is 0, c is 0, p is my 0, q is my 0, r is my 1. Now can you expand them? It is a minus of 1, 1 minus 0, it is a minus 1. So from here you can see d1 is 1, d2 is minus 1. So this option is cancelled, this cancel, this cancel. Only correct option is my here. Is a very simple way you can solve the problem within a 15 seconds. Remember, there is no condition on the A, B, C. So you can choose as per own convenience. Okay, look at this one. So a is given to you, a raised to power here. Again a very simple, very simple question is there, because this is my cos and sine. This is my cos and sine. So whenever there is a cos and sine, what is the a raised to power n? It is nothing but n into theta. This is the general formula for that. Now what is the value of the n? What is the value of the n is? N is my 215. So n is my 2015. Theta is my 2 pi over 31. So what is the n into theta? So 2015 over 31. So if you divide them, it is 65 into 2 pi. So what is that? 65 is my proper integer. So if I substitute here cos 2 pi theta, so that value will be my 1. Sin 2 pi theta is a 0, it's a 0, it's a 1. What is that? This is nothing but my identity is the right answer. Okay, look at this another one. So V is the vector space of the dimension R. T is my mapping from V to V, defined like here. This is the mapping given to you. Then is the ordered basis of V1, V2, V3. Then what is that? Whenever there is a ordered basis of this is given to you, this is the value corresponding to my V1. This is the value corresponding to my V2. This is my corresponding to V3. And we all know the linear transformation mapping will goes to here. So what is the V3? Since V3 is my non-zero, so this will be cancelled. V1 plus V2, so it's a 0, it's a non-zero, it's a non-zero, it will not be here. V1 plus V2 plus V3, so first 0, second 0, third 0, so it's a 0 mapping goes to the 0. V1 plus V2, V1 plus V3 is not equal to V2. V1 plus V2 is not equal to here. 3 minus 4, it is not same. So this is also cancelled. So the right answer is only C is the correct answer. Okay, which of the following is form a vector space? So we all know W is said to be the vector space if the zero identity elements belongs to this, and alpha g plus is also belongs to them when alpha beta is the real numbers and f and g is already in here. So these two property must satisfy. So look at that. Firstly, look at this pair. This is the identity, this is the 1, which is, it means 0 does not belong to the S2. So this option is cancelled out. So only S1 S2 or S2 is a cancel out. All the three are vector space cancel out. Now we have to just check only S3 and S1. Look at that. The first pair S0 satisfied S1, and you can see if F and G are, if I say F and G is in my S1, what is the meaning of that? Limit of the F and G both are my 0. So if you apply the limit on this, it will also go to the 0. So S1 is my subspace. Now we have to check S3. S3 means the limit of the Hx exists. What is the value of the existence? It is not given to you. If he said limit of the Hx is my L, then again if L is my non-zero, then again it is not a subspace. But he said existence. So what I can do? I can choose F and G from the S3. So it means the limit is also exist. If I take the limit from here, x approaches 3, it means it is also exist. So once the condition, and 0 also, why the 0 exists? Because h of 0 is 0, it's a limit. H of 0 is exist. So it means this is also the subspace, or sorry, is a vector space. S1 and S3 both are the subspace. Only S1 is a cancel out. Right option is third is the correct answer. Okay, this is the same manner I have discussed you earlier. So what is that? It is my, it's a mapping from P2 to P here. Then you have to define the matrix. What is the size of this matrix? So what is the dimension of the P4? Less than equal to n. So dimension of the P4 is my 5. Dimension of the P2 is my 3. So this matrix should be of the 5 cross 3. This into this. What is the mapping is given to you? transformation is my P of x square. So that's very simple. If I write this matrix here, 1x, x square, x cube and x4. Fine. Now if I consider the one mapping from the P2, what is the mapping of the P2 is 1x and x square. Fine. If I consider as a 1, that is my P of x. It is 1, then it is again a 1. So that's my constant, rest are my 0. If I consider P of x is x, it is a x square corresponding to x square. That is the third element. Corresponding to x square, it's my 1. Rest values are my 0. If I consider the x square, it is my x raised to power 4. So the last element, rest all values are my 0. Then it is not a linear transformation, wrong, because it is always a linear transformation. Now you have to find the range. What is the range? You have to find the rank. So clearly says the two zeros are here. So the rank of the matrix is my 3. So range is also my 3 is the right answer. Look at one more example of here. So which is my P3 to P4, where is a polynomial of degree less than equal to n. So this has the dimension 5, this has the dimension 4. So you have to construct a matrix of 5 cross 4. So what are the elements of the 5? 1 x, x square, x cube, x4. So what is the dimension of the 4? So P of x is my 1 x, x square and x cube. These are the elements of the here. Now we can substitute. Now look at that. I need a second value. I need a second value. That means I need a second column. So second column I need a corresponding to the x. So if I take as x here, what is that? This is x square. What is the derivative is 1 plus integration of x is x square by 2. So what is that? This is 3 by 2 of x square. So this is x square. Third element is my rest values are my 0. So what is that? This is a, this is the third row, A32, A32, these options are cancelled out. Now look at this third column. Third column is corresponding to the x square. If I substitute here as x square, so it is x square derivative is my 2x plus integration of the x square, x cube over 3 when you take the limit 0x here. So it is my 2x cube plus x cube by 3. So 6 plus 7 by 3x cube. So x cube, that's a fourth element. So this is my 7 by 3. Rest values are my 0. So A33 is my 0. So this is the right answer. This is the cancel. Look at the one more example here. This is again the transformation is given to you, but here it is in the form of the x comma y. Look at that. In this previous case, you have a polynomial of n, then the dimension will be n plus 1. But here it is a function of the two variable. So when you have the function of the single variable, then the dimension of the polynomial will be n plus 1. But when you have the function of the two variables, then the dimension of the polynomial will be n plus 1, n plus 2 divided by 2. If it is of the 3 dimension, x plus y plus z, then you can write as a n plus 3 divided by 3. Now it is of the 2. What is that? Degree less than 3. So I can less than equal to 2. So n is my 2. I can substitute here 2 plus 1, 2 plus 2. So what is that? It's my 6. So this t is my 6. So this is also the 6th dimension. This is also the 6th dimension. So I have to construct a 6 cross 6 matrix. What are the elements are there? 1 x, y, then x square, y square, and then x. These are the elements. So I can written like of here 1 x, y, x square, y square, xy. So look at the first element, and function is partial derivative. So if I take the first pair, the partial derivative is 0. That's a constant. Rest values are my here. Second element x, partial derivative is my 1, which is a constant. So corresponding to the constant line, rest values I can written like here. Y, partial derivative will be 0, again constant. So I can written here. Rest values are my 0. X square, partial derivative will be my 2x, so coefficient of the x 2, rest values are my 0. Y square, partial derivative will be my 0, so it's a 0 here. And the last line is here, the partial derivative of x will be y, so it will be partial derivative of x is y, so coefficient of y is 1, rest values are my 0. Then you have to define the nullity. You can see T is invertible, cancel out, because the rank of this matrix T, how many non-zero rows? 3 are the 0, so it is my 3. So it means the determinant of this will be a 0. If rank, then you have to define the nullity also. So rank of the T is at least 3, at least 4. At least 4 means greater than equal to 4, that is cancel out. At least 3, equality is satisfied, so this is the right answer. Nullity, so how you can define the nullity? So nullity will be my n6 minus rank of the A. So if I say it is a less than 3, so it will be greater than or equal to 6 minus 3, greater than equal to 3. So that is at nullity will be at least 3. So this is, but this is also there, nullity is also be a 3 is the right answer. So the first and the third are the correct answers of this problem. So because this is at most at least 3, this is sorry, this is at least, sorry, this is wrong, this is at least means this is greater than equal to 3, so equality is satisfied, so that's the correct option. So but it is my greater than, so it is my less than 3, so less than 3 means it is less than equal to 3, so it is at the most 3, this is at most 3, so this is my cancel option. So right answer is only third option. Okay, now look at that, which of the following will form a basis? What is the meaning of the basis is Li and the span. So but there is no need to check the span. What is the dimension of the B1? This is 4, which is same as that of the dimension of the R4. If both the dimensions are same, so span will automatically be there. You have to check only Li. So for the B1, so firstly we will check that B1 is already be there, so there is no need to check for the B1. So B1 is a basis definitely. B2 not B2. So we will check firstly for the B2. So these are the first values I can written as a column vector: 1 2 0 0, 1 2 3 0, 1 2 3 4. So clearly says that if I consider this as my A, what is that? Determinant of A. This is a diagonal matrix which is a non-zero. It means this is Li. It is a Li, it means this is my basis. So only L1 is the cancel out, not B2 is also cancel out. Now we will check about the B3. We can write in the column matrix 1 2 0 0, 0 0 1 1, 2 1 0 0, minus 5 5 0 0. Fine. Now you can see I can easily make R4 minus R3 as a 0. So this value will be my 0. So clearly says that determinant of them is a 0. It is not a basis because it is my LD. So LD implies is not a basis. So B3 is not be there. So right options are my B1, B3 is not there. So B1 and B2 are the basis, but not B3 is the right answer. Okay, look at that. What is that? S and T are the mappings such that T circle S is my identity mapping of this. So clearly say that this is my R cube to R cube. Then what is the S circle T? So what is the S circle T? So you have to apply R4 to R4. Firstly you have to apply the T, that is my here, to this. Now remember, if one mapping is my identity, and second mapping is also be the identity, what is the meaning of that? This S and T, both mappings are my identical. Both mappings are my identical, but they are not identical. Why? Because these are the elements of the R3, these are the elements of the R4 in the domain. It means if one is identical, this is my not identical. So first option is cancel out. Second tips, if S circle T is not identical, what is the meaning of that? It is not my bijective. So once it is not my bijective, it is neither a, this is my correct option, these all are my cancel, because he said it's a on 2, but it is not an on 2, it is not a 1 1, so the right answer is only fourth is the correct option. Okay, look at this power series. So you have to find the radius of the convergence. So what is the radius of the convergence? We all know this is the limit supremum of an of this, or you can write this as a limit an plus 1 over an. But how you find the an in this example? An is the number of divisors of n raised to power 50. So that's a very simple. I think you all of you remember that number of the divisors are always be denoted as of this notation. So remember, number of the divisors are always be like here. Fine. Now you need to find the divisor of n raised to power 50. So what is the meaning of that? I can replace n to be the n raised to power 50. Fine. This is my an. Now this is the power, so I can take 1 raised to power n on the both side. This is my 1 raised to power n, and this is 50 by n. And you all know limit n raised to power 1 by n as n approaches infinity is always be a 1. So what is that? This is my 1. This is my an raised to power here. This is my 1 raised to power 50 is my 1. So it means this value is my 1. So 1 over 1 is my 1 is the right answer of this problem. Again, you have to find the radius of the convergence. So what is that? If I open this value of the n factorial and 1 to infinity, it is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, that is a polynomial. So what is my an? 1 in each case. So what is my an plus 1 over an? Again 1. So the radius of convergence is my 1 is the right answer. Okay, k is my positive integer. Is it given to you? What's the value of the k? So you can choose any of the value, positive integer. So I can choose k is my 2. Then what is the k? K is my 2, 2n factorial. Fine. Then you will find the an plus 1 over an. That's very simple. N plus 1 over n factorial. I can make a pair, and it is my 2n, and this is my 2n plus 2 factorial. So how I can that? I can open this n plus 1, n factorial will be cancelled out. I can open this denominator part, 2n plus 2, 2n plus 1, after that 2n, so it will be cancelled out. One of this will be cancelled out, it will be the remaining is 2, so the remaining part is n plus 1, 2n plus 1 over 2. So take the limit as n approaches infinity. So 1 over here, so 2 times 1 over this, so it is my 1 over 4. So therefore, what is the radius of the convergence? 1 over an plus 1 over an, that is my 4 is the right answer corresponding to k is equal to 2. So this answer will be 2. So this option is cancelled. It is 2 raised to power minus 2, 1 by 4. This option is cancelled. Infinity cancelled. 2 raised to power 2 is the right answer of this problem. Again, you have to find the radius of the convergence of this. So again, if you open them, it is my 1, 4, 3 will be 9. Again, it's a polynomial. It's a power series. What is the coefficient of each term? 1. So once is a 1, so radius of convergence is also be a 1, because if you take as 1 over limit an plus 1 over an, what is that? 1 over 1 is the right answer. Okay, A is any 5 cross 5 matrix such that characteristics polynomial of the A is characteristics polynomial of the A inverse. So that's a very simple. You have to check about the options. What is the nature of this A? It is invertible. You can, is it given to you that it's a symmetric or the skew symmetric or Hermitian or there? No. So you can choose any of the 5 cross 5 invertible matrix. Think about any of the easiest matrix. I. Fine. What is my A inverse? A inverse is also I. So what is that? Characteristics polynomial of this, characteristics polynomial of X are same. Now what is the we need a trace. So firstly we need a power 2 and power 5. What is the A square? It is again 5. I. A5 is again I. What is the trace of A square? What is that? What is the eigenvalue of the A? Eigenvalue of the A is my 1 1 1. So what is the A square eigenvalue? Again 1 1 1. So the trace will be my 5, but he said trace will be 1. Cancel out. Again, what is the trace of A raised to power 5? Is 5. This will also cancel out. If A has eigenvalue 1, so what is the eigenvalue of this is 1 1. Eigenvalue of the A raised to power 5 is also be a 1 1. So determinant are same, but our target is to cancel the options. Now how you can, now you have to think about the second example. So if I consider A is my minus I, what is the A inverse? Again minus I. Eigenvalue of the A is my minus 1 minus 1 minus 1 minus 1. Eigenvalue of this is A. Eigenvalue of the A square is 1 1 1 1. Eigenvalue of the A raised to power 5 is minus 1 here. Now you can see what is the product of the A square. Product of the A square, that is a product of the eigenvalue is nothing but the determinant 1. Product of the eigenvalue is my, so you can see this option is cancelled. Only left option is A. This is the right answer. Okay, now this is a Jordan canonical form. So what is that? Whenever you are working on the Jordan canonical form, there is a need of the two things. One is the characteristics polynomial, second is the minimal polynomial. If both are given to you, then it's very easy. Otherwise you have to firstly find them. So what is that? It is here and this is my. Now what is the meaning of that? It means first of all you have to find the eigenvalues. Eigenvalues are my 2. From this characteristics polynomial you have to use the algebraic multiplicity. From the minimal polynomial we will use the geometric multiplicity. So algebraic multiplicity of the eigenvalue 2 is my 4. It means whenever you are trying to write the Jordan block, 2 appears 4 times. So look at that diagonal 4 4 4 4, all are correct. Now look at the geometric multiplicity power of this. So it's a 2 power. So it means 2 occurs at most 2 times. Whatever the power is there, that is there. It means that means it is a less than of 2. It means is either 1 or either 2. It means this will represents about the pair. If I call as a 1, what is the meaning of that? 2 occurs only 1 times, like of this 1 times. 2 means the pair of the 2 occurring here. Fine, pair of the 2 occurring like this way. So firstly we will check about which option not satisfied. So these are the single 2. So these are the single 2 satisfied. These are the single 2, but you can see this is the one pair satisfied. Either this is 1 or 0, or you can write as below 1 or 0. So this is satisfied, and look at that, this 1 is extra, this 1 is extra, so this is a cancel out. Look at that, this is my single, this is my single, this is my occurring. You can see at one pair of 2. So this is satisfied, and this is my 2 single times. This is also the correct option. Look at this one, this is fine. This is not true, because algebraic multiplicity, this is also true because it is a Jordan block of 2 times. So these 3 are my correct options of this example. So algebraic multiplicity is 4, so 2 written 2 times. There is a one pair of the, either you can write 2 as a 1 times or 2 as a 2 times. No, this, yes, 2 as a 2 times is the right answer. What is that? It's a 2 occurring as a 1 pair, only 1 pair. So but here as a 2 pair, at the most 2 pair, that's fine, at the most 2 pair. So this is fine, is the right answer. Again you have to write the Jordan canonical form, but in this example you can see in the previous case canonical form, characteristics and minimal polynomials are given, but in this example it is not given. So you have to write the characteristics polynomial, you have to write the minimal polynomial. So one way is you can start from the a minus lambda I, but what is the shortcut trick for you? Look at the diagonal values. If diagonal values are my 0, so the characteristics polynomial will be my lambda raised power 4, and the first step is look at the diagonal values if all are my 0, and either the below values are my 1 or upper value is my 1. One of them is satisfied. Look at that. In this case, the below values are satisfied. Then you can write the minimal polynomials directly. How you can write? Below are my 1. So start from here. Minus 0 lambda cube. Minus 5 lambda square. Minus 0 lambda. Minus plus 4. Clear? I can repeat for you again. Firstly, look at the diagonal values. If diagonal values are my 0, then look at the second diagonal entries, either below 1 or upper 1. Only one condition will be happen. So if below are by 1, you can start from here. So I can start from here, this value, because diagonal values are 0, so it starts from here. Minus of 0 this, minus of 0 square, minus of 0, minus of 0. On the other hand, if these values are my 0 and these values are my 1, then you have to start from here. These values are my 1, okay, then this and this, and similarly you can write here. Now what is that? This is lambda 4 minus 5 lambda square plus 4. This is the characteristics polynomial, and same are there. Whenever you are trying to find this method, characteristics and minimal both are same. So what is that? You can write the factor lambda square minus 1. So what is that? This is lambda minus 2 plus 2 minus 1 plus 1. So what are the eigenvalues? Eigenvalues are 2 minus 2 minus 1 plus 1. What is the algebraic multiplicity of this? Each one. So since they are the distinct, so characteristics polynomial is same. So it means what is the minimal polynomial? Power is 1. So Jordan block is of 1 nature. So this is the 1, this is the 1, this is the 1, this is the 1. Correct option. This is not a 1 because of this 1 extra. It is cancel out. This is 1 extra, cancel out. This is 1 extra, cancel out. Right option is only first option is the correct answer. Okay, now look at that. A is any 2 cross 2 matrix over the R. Then you have to find such that which satisfied this. That's very simple. Let's say A is my 2 cross 2. What are the eigenvalues of my 2 cross 2 matrix? Here, these are my eigenvalues. What is the eigenvalue of the A plus I? We all know eigenvalue of the I is my 1. So these are my here. How you can find the determinants? That is my product of the eigenvalues. Right hand side is product of this. Now if you open this bracket, you will see rest are cancel out. What is that? Trace of A is my 0 is the right answer. That's a very simple straightforward task for you. Okay, look at this another one. N is my positive integer, M is my n cross n, so I can simply take n is my 2. So this is my 2 is my 2 cross 2 matrix. So it is my 2 here, such that T of A is my 0. So T is a linear transformation such that, so collection of all those, M of 2 is my here. If I call this is my H, then the rank of this, you have to apply the rank of the T. So I can use the rank nullity theorem. This is the dimension of the vector space of the M2. Fine. So what is that? This is a nullity. This is a nullity. So what is the size of this? 4. 2 cross 2. That's the dimension is 4. What is the dimension of the M2? It is also be a 4. So what is the rank of the T? It's a 0. That's a straightforward task for you here. Look at the another one. So f of x is a minimal polynomial of the 4 cross 4. Again, you can see diagonal values are 0 and below values are my 1. So the eigen minimal polynomial is my lambda 4, these are my here. So start from here, 0 cube, 0 square, 0 and minus 1. So the minimal polynomial is my here, characteristics polynomial is here. Fx is the minimal polynomial, then the rank of the 4 cross 4 of the f of a. So what is my f of a? So f of a is my here. So according, if this is the characteristics polynomial of the fx, so what is that? F of a will be my 0 by the Cayley-Hamilton theorem. So what is that? These both are same. What is the rank of this 0 matrix? It's a 0. So it means rank of the f of a is also be a 0 is the right. So you can see, once you know the characteristics equation, so by the Cayley-Hamilton theorem it's satisfied. So f of a must be a 0 is the right. Okay, a is my 5 cross 4 such that ax is 0 if and only if x is my 0. What is the meaning of that? When this will be the trivial solution, when determinant of a is my non-zero. So but a is my 5 cross 5, you can't find the determinant. What is the meaning of that? Rank of the a is my number of the column vectors. Fine. So what is the number of the column vector? 4. So you need to find the rank. Rank of the column vector is 4 is the right answer of this one. Which of the following has the same row space? What is the meaning of the row space is? You have to find the rank of this matrix and the rank of the others. So what is the rank of this? Rank of 2, all are my 2. But yes. So which of them is reduced to this form? So clearly say that if I, what is that? I can firstly divide it by here, 3, 6, 1, 2, 4, 0. Fine. Now I can multiply by 3, it will be 0. Multiply by 3, 0, it's a minus of 2. Then multiply by 2 is a 0, 0, minus of 2. Then I can written as, I can make this value as a 1 and I can make this value as a 0, 1, 0. Fine. So what is that? Rank is 2, 1, 2, 0, 0, 0, 1 satisfied, 1, 1, 0 not satisfied, 1, 0, 0 not satisfied because of this 2. So the right answer is only the first option is the correct answer. Okay, A is my 3 cross 4 having the rank is my 2, okay, which is less than of number of the column vectors. Then the rank of the A transpose A, again a very simple, very simple. So firstly you can check, discard the option. What is the rank of the AB? We all know it is less than of rank of A, rank of B. Fine. So what is that? Rank of, and we all know rank of the A, rank of the A transpose are same. So it means it is a 2 and 2 less than equal to 2. Exactly 3 cancel, exactly cancel out of these two options. Now if I consider this value as my B, fine. So it means I need to find the rank of the B. If I apply the nullity and the dimension of this mapping, what is that? A transpose is my 4 cross 3. If I multiply this by A, it will be my 4 cross 4. So it is my dimension is my 4. Now as usual we can see, since the dimension is my 4 and the rank of the A is less than of their dimension, so it means the nullity of A transpose of the A is my nullity of A always. So what is the nullity of A? Again you can't say that. So once the nullity and same, so what is the meaning of that? Because it is my fixed 4, if I substitute here, so the rank of A transpose A is same as that of the rank of the A. So this is my 2. So rank of the A transpose is exactly 2 is my right answer. Okay, next one is J is a matrix of order n cross n. all entries are my 1, B is my, again you can choose the value of the n as your or convenience. If I take n is my 2, then it will be 6 cross 6. That will take a lot of time. I can choose n is my 1, it will be 3 cross 3. So what is that? J is my 1 cross 1 with all entry 1. So the matrix is only 1. So what is that? This value will be 0 1 0 1 0 0. So what is the rank? Rank of the B. Rank of the B is my 3. So I take as n a 1. So this is a 1, not true. When I take n is 1, it will be 2, not option. So the only left option is my 4th is the right. You can see that without solving, whenever you are working on the linear algebra, reanalysis, calculus operation, eigenvalue, there is no need to solve much calculation. Think about the problem, solve within a fraction of a second always. Okay, for the fixed positive integer n greater than 3, again it's n cross n. So I can choose n as per on simplest. So n is my 3 is I can choose as here. So A is my 3 cross 3. I is my identity, J is my 3 cross 3, all entries are my 1 1 1. Fine. So that's again a very simple. Which of the following is not true? Here n is my 3. Now what are the eigenvalues of the J? Eigenvalues of the J are 3 0 0 because this is the row sum is same 3 and the diagonal is my here. Eigenvalues of I is my 1 1 1. So what are the eigenvalue of the A? These are the 1 1 1 minus 1 0 0. So what are the eigenvalue? 0 1 1. Fine, it is clear. Now one of the eigenvalue is 0. What is the meaning of that? Determinant of the A is my 0. Trace of the A is my 2. So AK is equal to A. You can see if for any positive integer k. So if I say k is my 2. So what are the eigenvalue of the A? Eigenvalue of A is here. What are the eigenvalue of the A square? 0 1 1. So characteristics polynomial same, minimal polynomial same, it is always same. Trace of A. What is the trace of A is my 2, which is n. N I consider as a 3. 3 minus 1. 2 satisfied. But we need a not. This is my correct statement. This is my correct statement. Rank of A. So what is the rank of the A? 2. Rank of the I minus A. Now what is the eigenvalue of the I minus A? These are eigenvalue of the A. Eigenvalue of the I is 1 1 1. Eigenvalue of this is my here. So what is that? This is 1 0 0. So rank is my 1. So this is eigenvalue 2. These are the rank is 1. It is my 3 satisfied. This is also 2. A is invertible. We already say that determinant is a 0. So A is not invertible. So it is a false state. Again it is my n cross n. So it's again I can simply take as a 2 cross 2. Which of the following is my true state? Again a very simple. You can think about that. Firstly look over that. If I simply take A, B both as I, is it satisfied this condition? I plus I square is I minus I cube. I cube is I, so it will not be satisfied. So it means both can never be same. Both can never be same. Okay, look at this one. How you can make them? Just think about that. If I take A is my something, say B is I and A is my minus I, is it satisfied? What is the my BA? Is a minus I, B square is plus I. It is I, B minus A square. So A square is my plus I, so it's my 1. So I minus I is satisfied. So now I can think about these options. A is my non-singular. What is the meaning of that? Determinant of A is my non-zero. From here it is satisfied. Determinant of B is a non-singular, is my again satisfied. A plus B is my non-singular. What is the A plus B? You can see A plus B is my 0, but he said determinant of A plus B is my non-zero, but we get at least one value. Cancel. Fine. Now AB. What is the AB's? If you multiply them, it will be minus of I. Again determinant is a non-zero. Again it's satisfied. So from this example we cancel out the third option. Now Look at this another pair. If I consider A as my 0, B is my say I. So this value will be 0, this value will be I, this is I, this is 0, again satisfied. So you can see what is the determinant of this matrix? 0. So this option is cancelled out. What is my AB? AB is also 0. So this option is also cancelled out. The only left option is my B, is the left behind, is the right answer. If you think that I can take B as a 0, A as a I, does it satisfy this given condition? B A 0, B 0, I 0. So it is not satisfied. So it means B can never be 0. So this is the right answer of this problem. Okay, look at this again. It is not given to you the value of the M. You can choose any pair which satisfied this property. So I can choose M is 1, N is my 2. Then my target is to prove AB is non-singular. This is non-zero. AB is always singular. Singular means this is my 0. BA is always non-singular. It is non-zero, and BA is always singular here. So I can choose any pair. Let's say A is my N cross, so 1 cross 2. This is my here. B is my N cross M, 2 cross 1. Fine. Now look at that. I need a AB. What is my AB? 1, which is a non-zero. That's true, but he said AB is a 0. Again, it's a non-zero, so this option is cancelled. Look at the BA. What is the BA? 1 0, 1 0. So what is that? This is 1 0 0 0. So what is the determinant of BA? It's a 0, but he said BA is a non-zero. This option is also cancelled. Now look at this example is over. Now we can think about the another example. Say 1 0. I can change, just B is there, 0 1. So what is my AB? 0 0. But he said AB is my non-zero. This option cancel. Only this option is left. If I compute the BA from this, what will happen? 0 1 1 0. So what is that? 0 0 1 0. Fine. So determinant is a 0, which satisfied this property as well. So the right answer is my D, is my correct option of this example. Again, you can see that very simple, very easy. You can just think about the examples in a examination. Okay, A is my N cross M matrix. Again, what is the M and M not given to you? So you can choose any pair. Any condition is given to you? No. So you can choose any M or N. This is my A. Look at that. Every column has exactly 1 and exactly 1. So good. Look at that. My option is N is my less than equal to M. Fine. So I can choose the reverse side. I can choose M is my say 2 and N is my 3, for example. So that option will be cancelled out. So if I say it is my N cross M, 3 cross 2, exactly 1, exactly minus 1, 0, exactly 1, exactly minus 1, 0. It is my 3 cross 2. Now what is the rank of this? Clearly say that the rank is my 1, because I can make this as a 0 as well. So rank of 1, what is the N? Less than equal to 2, that's satisfied. Rank is my 2, but M is my 2, it is cancel out. N is less than equal to M, cancel out. N minus M, 2 less than equal to 2, again satisfied. Now there are 2 options. So I can increase these values. I can fix the value of the N. I can increase, fix here. It is my 4 cross, because it has exactly 1 plus 1, exactly plus 1. So rest our values are my 0. Again, rank of A is my 1, N is my 4. So 1 is less than equal to 4, minus 1 satisfied. But here N minus 1, 3, can't be less than equal to 2, no. So this option is cancelled. Only left option is my A, is the right option. So that's again very simple. Choose any pair of the N and M which satisfied this condition. Okay, look at that. P is a matrix such that p square is equal to p. What is that? This is idempotent matrix. So trace of the p. So if I consider p is I, it's satisfied properties. What is the eigenvalue of this I? 1, 1. So what is the trace of this matrix P? 2. Irrational number, cancel. Trace imaginary number, cancel. Trace is an integer, it's satisfied. Trace is equal to rank. So look at that. One simple tips for you: whenever there is an idempotent matrix, then rank of A is trace of the A square is equal to A. Moreover, rank of the I minus A is same as that of the trace of the here. So you can see that trace is an integer, satisfied. Trace is rank is also satisfied. But how we can say? We can see here. This is my I. If I say this is my I, what is the rank of the A? 2. What is the trace of the A? 2. If you think about here, if I consider the eigenvalues are my 0 and 1, because it is my x square minus x is equal to 0, so then I can consider this value also. Fine. So clearly say that if you multiply, if I say here, if this is my p, then what is the p square? Again a p. So what are the eigenvalues? Eigenvalues are my 1, 0. What is the rank of this matrix? 1. Trace is my 1. So you can say this is always 2. So B and C are my right answer of this problem. Look at the next one. If A is my n cross n, again it is n cross n. Nothing is given to you, so you can think about any of these counter examples. Now how you can think about that? Say 2 cross 2. Which of the following is correct? A square is 0. What is the meaning of that? A square 0 means A is my nilpotent matrix. So once A is my nilpotent matrix, we all know A is not a diagonal. But he said A is diagonal, so it's a cancel. Look at the second option. A square is equal to I. What is the meaning of that? This is my involutory matrix, and we all know involutory matrix always diagonal. Okay, so it is a diagonal here. It's a satisfied. A square is equal to A, which is again here, which is the same kind of this. So it is diagonal only on this R. It is diagonal only on this R, but he said only on the complex number. Cancel. Last, because there is only one correct option, so that's over. But we will discard the option. The only matrix of the size 2 satisfying the characteristics equation is A. What is the meaning? Can you think about the two different matrix? Can you think the two different matrix such that they are not same, but their characteristics polynomials are my same? Can you think about that? Definitely. If I say 1, what is the characteristics polynomial? Lambda square minus 1, because eigenvalues are plus 1, minus 1. So these are here. If I think about here, so again the eigenvalue characteristics polynomials are both the characteristics polynomials same, but clearly says both are not same. So it means he said this the only matrix is my A of this nature, but it is not true. So this is a wrong option. Okay, now A and B are 2 cross 2 matrix. So sometimes the student think about like of this A, B, C, D and like of E, F, G, H. It will take a lot of the calculation, but you have to spend maximum of the 10 to 15 seconds to solve the examination problem. So firstly you can take A is equal to B is equal to I of 2 cross 2. Then what is the A minus B? A minus B will be 0. A plus B will be my 2i. Fine. So what is the determinant of A minus B? 0. Determinant of A plus B is my 4. Now look at the option. This is 4, 0. Determinant of this is 1. This is 1. Not satisfied. Cancel. This is 4, 0, 2, minus 2, 0, 4. Not satisfied. 4, 0, 2, 2. It's satisfied, but this is one counter example. We can't say that. If we discard the fourth option, then this is the right answer. 4 minus 0, 2 minus 2 cancel out. So the only left option is my C is the correct answer. Now look at that. Next one is A is my 4 cross 4 invertible matrix. Determinant of A is my non-zero. Which of the following is not necessarily true? What is the meaning of that? If you have this 4 by 4 matrix whose determinant is a non-zero, rank of A is my 4, then first option, row of the A form a basis. So what is that? If determinant is a non-zero, it means they form a Li. If they are Li, it form a basis. So each row space as well as the each column vectors form a basis. So this is my correct statement. The null space contain only the zero vector. So we can apply the nullity theorem. Rank of A, nullity of A is my 4. Find number of the column vectors. Remember, this is always with the number of the column vector. So what is the nullity? We have to find. Rank is my 4. So what is the nullity? Nullity is my 0, and he said it's a 0 vector. It's a correct option. Now look at this. A has 4 distinct eigenvalues. That is not true. If I consider A is my identity, it's a 4 cross 4 invertible. So determinant of A is 1, which is non-zero. What are the eigens value? 1, 1, 1, which are not distinct. So this is my false statement. So this is the right answer. Image means rank of this is of the R4, because the rank is my 4. So it is my 4 is the correct statement, but we need a false statement. So the right answer is only C is the right answer. Okay, which of the following is my correct statement? If you have the if n is my, again, the easiest way I can consider as a 2 cross 2, such that the set of all these non-zero eigenvalues. What is the meaning of that? If I write in terms of mathematics, lambda is my non-zero, has exactly R values, then which of the following is my correct statement? Very simple. A is my 2 cross 2. If I consider A is my identity, 2 cross 2, fine. Then what are eigenvalues? Eigenvalue is my plus 1 and 1. Non-zero eigenvalues. So any value of this, so S1, non-zero eigenvalues here. So what is that? Exactly R elements. It is exactly, how many values are exactly 1 elements? So R is my 1. What is the rank of this matrix? Is my 2. So rank is my 2 is less than equal to 1. First option is cancelled. Fine. Look at this another option. R is 0. What is R? Is set of all non-zero values. So that's again a very simple. If I say R is 0, if I say the diagonal values are 0 and say 1, 0, 1, for example, what is that? Eigenvalues are my 0, 0, 0. So this set S is my empty, so R is my 0. But what is the rank of this matrix? Rank of this matrix is my 2. So this is my 2 is less than equal to 2, n is my 3 cross 3. So 3 minus 1, it's satisfied. But is it always true? We can't say that. So how you can, we will look about the another example. Rank of A is my 2 greater than equal to this satisfied, but this is a counter example. A square always has a distinct value. So if I say these are my here 2 cross 2, R is my 0 because there are non-zero value. Oh, no, sorry. What is the R? R is my 2 because they have the 2 non-zero distinct value. So this set consists of here. What is my A square? 1, 1. So it has 2 eigenvalues but which are non-zero. So what is the R is my 1, which is not same. Now look at that. This rank of A is greater than equal to R. If I consider the 4 cross 4, R I consider here as non-zero value, that's over. So 4 cross 4, 0, 0, 0, 0, 0, 0, 0 here. If I consider this is also the non-zero. What is that? Rank of the A is my 3, What is the R? Non-zero distinct value is my 1. 3 is greater than R. So this is always true. C is my correct. Look at this way. R is 0. So if I take R is 0, if I consider this value as a 0, then R is 0. Rank is my 3. So 3 is less than equal to 4 minus 1. Again satisfied. This is also the right answer of this problem. Remember, if in this example, if he said rank of A is strictly less than of the n minus 1, then we already discard through the second 2 cross 2, 3 cross 3 case study. Okay, which of the following is my not diagonal? How you can check about the diagonal? If you have the distinct eigenvalues, then it is a diagonal. If you prove that algebraic multiplicity of this lambda, geometric multiplicity of this lambda are same, then it is a diagonal. But we said not. Look at that. Eigenvalues are, they are my distinct, so it is a diagonal. But we said not. This option is cancel out. So look at same. The eigenvalues are 1, 2, 3. They are the distinct eigenvalues. So it is not. It is a diagonal, but we need a not. They are the distinct eigenvalues. Look at the first option. Eigenvalues are 1, 2, 1. Algebraic multiplicity of the 1 is my 2. Algebraic multiplicity of the 2 is my 1. So this is a distinct. There is no problem. If I prove that algebraic multiplicity of the 1 is 2, then it is a diagonal. How you can find the geometric multiplicity? That is very simple. N minus rank of A minus lambda I, corresponding to which eigenvalue you want. So for the first case 3, rank of, I need to find the 1. So this is my 1i. So what is the A minus 1i? So it is a 1, it's a 0, 1, 0, 0, 1, 0, 0, 0, 0. What is the rank? Clearly say that 2 columns are my 0. So this rank of this matrix is A minus I. What is the rank of this is my 1. So 3 minus 1 is 2. So geometric multiplicity of the 1 is my 2, which is same. So once it is the same, it means this is also be a diagonal. So this is cancelled out. Only correct option is my C is the right answer. How you can do? Again we can see these are the 1, 1, 2. Algebraic multiplicity of 1 is 2. So we can find the geometric multiplicity corresponding to 1. 3 minus rank of, if I substitute 1, A minus I, because lambda is my 1. 0, 0, 0, 0, 0, 1. What is the rank of this? 2. 3 minus 2 is 1. Algebraic multiplicity 2, geometric multiplicity 1, which is not equal to 2. So this is my not diagonal matrix. So this is the right answer of this problem. Okay, look at that. M is my 3 cross 3 matrix. 1 is the eigenvalue of the M. So there are the 3 eigenvalues. One eigenvalue is given to you 1. What are the other eigenvalues? First method is you can find this A minus lambda is a 0, but it will take again a very large time. So the easiest way is look at the row wise and the column wise. What is the tips for you? If column sum is my k, if each column sum is my k, or if each row sum is my k, fine, then k is one of the eigenvalue. Look at that. If I take this row, it's a minus 1. It's not the same. Look at the column wise. It's a 2. Column wise 2. Column wise 2. Each has the same. So one of the eigenvalues is my 2. How you can find the third eigenvalue? Third eigenvalue you can find the sum of the diagonal entries is the sum of the eigenvalues. So trace is my 5. So 2, 3, another value is my 2. So minus 2 is the eigenvalue, cancel. 3 is the eigenvalue, cancel. M is diagonal. So again, algebraic multiplicity of 2 is my 2 because they are the 2 elements. So we can check about the geometric multiplicity of 2. How you can do? It's a 3 cross 3. Rank of A minus lambda is my 2i. So what is that? What is the rank of, I can subtract A minus 2i from here. The first value is minus of 2, minus 1, 0, plus 1, 0, minus 1, 1, 1, 1. So how you can find that? If I add them and subtract from the upper value, it is a 0, 0, 0, 1, 0, minus 1, 1, 1, plus 1. Now I can add them up above. It is my 2, it is my 0. So what is that? So now you can choose this. What is the rank of this? Clearly says that now there are the two values. I can make this value as a 0 with the help of this. So there are the two non-zeros two non-zero column vectors are there. So the rank of this is my 2. So 3 minus 2 is my 1. So they are not same. It is not diagonal. It is a cancel out. This is the right answer of this problem. How you can say what is the meaning of the eigenspace? This is nothing but my geometric multiplicity. Geometric multiplicity of the each eigenvalue. What is the geometric multiplicity of 1? Is a distinct elements is a 1. What is the geometric multiplicity of the 2? I already computed as a 1. So each has the dimension 1 is the right answer of this problem. Okay, look at that. T is my real number. So you can choose any of the real number. I can choose as a 0. Then determinant is 0, determinant is 0. What will happen if my T is 0? This is my 0, this is my 0. What is my determinant? 1, which is non-zero. This option is cancelled. Fine, because it is for all. It is a polynomial of degree and then so on. Now, how you can expand them others? So I can open it. 1 minus t square minus of t, 1 minus 0 and 0. So what is that? This is 1 minus here. So this is the determinant of here. Now look at the first option. It is a polynomial of degree 3. Determinant is 0 for infinitely many t, but this will be 0 for only two values because it's a quadratic. So this option is cancelled. Exactly 2 value is the right answer of this problem. Okay, now look at this another example. N is my positive integer. Hn is the subspace of 2 cross 2. So I can take n is my 2. Simple. So Hn is my 2 cross 2 matrix. Fine. Such that Aij is Ars. What is the meaning of that? Aij like of 1, 2. So the sum will be 3. Any other pair? 2, 1. Like if I say 1, 3, the sum will be 4. So what are those? 3, 1, A, 2, 2. All are 4. They are the same. Then which of the following is my correct option? So look at the A11. There is 1, 1, 2. There is only one element I call as a A. This is A12. A12 and A21 are same. If I call this as a B, there is no need to find this element. This is A22. 22 will be not be there. So how many dimensions? It is my 3. Look at the option. N is equal to 2. It's a 4. Cancel out. It is my 4 minus 2 plus 1 is a 3. That could be there. This is only correct option if rest are cancelled. 2, 4, 5 is a cancel out. It's also the 3. It is 3. It is 3. Both are there. So we can't say both are correct option. Then we have to think about the another case. That is n is equal to 3. Then it is my 3 cross 3. A11. Fine. A12. A12 and A21 are same. So there is no need to find. A13. A13 is my C. A31 there is no need. A22 there is no need. This element will be A23. Element will be 5. Then it is same as that of A32. A33 is a 6. That's a 7. So how many elements are there? Dimension will be 5. So if I take n as a 3, 3, 9 minus 3 plus 1, which is not equal to 5. So this option is cancelled. 6 minus 1 is 5. So both options, this is the right answer of this problem. That's a very simple target for you. Okay. The system of the equation has infinite many solutions. Very simple. How you can do that? We all know whenever both the ranks are same and they are same to the n. What is the n? Is number of the column vectors, then we will get as a unique solution. And when it is less than of the n, then we will get as the infinite solution. So number of the columns are my 3. So it means I need the rank of the A must be less than of the 3. When it will be happen? When determinant of A will be 0. Fine. So we can find the determinant 1, 1, 1, 2, 3 minus 1, 1, 2 minus k. So what is that? 1 minus 3k plus 2 minus 1 minus of 2k plus 1 plus 1 and 4 minus 3 is 0. So you can find the value of easily 2 minus 3k plus 2k minus 1 plus 1 is equal to 0. So it is my k minus k plus 2 is k is equal to 2 is the right answer. Make sure students, if you are using my shortcut tricks, you have to be very strong on your basic. You have to be very strong on your basic, then only such kind of the shortcut tricks will be applicable to you. So you must read all your mathematics subjects very strongly, very deeply. Okay, F is the mapping from Rn to Nr such that this will happen. What is the N? It means it is applicable from R2 to here, R3 to this and so on. So I can choose N is my 1. That's a very simple example. Then it is R to R such that this condition will be my F0 is equal to 0. Fine. Then this condition will becomes my N is 1. So it will be my only x square is less than equal to 1. Then this set. So what is that? X square is less than 1. What is the meaning of that? It lies between minus 1 to plus 1. It's a 0. Cancel. 0 cancel. A and B are there, but he said A is my greater than 0. Minus 1 does not belongs to this. Minus A plus A is my positive. So if I take A is my 1, which is a real number, it is my minus 1 to 1 is the right answer. Again you can see it's a very simple. I just simply take N as my own choice value. But I again ask you, you have to be very strong on your conceptual theory subject. Okay, what is that? Consider the row vector, dimension of the vector space. Very simple. This is a row vector 1, 1, 0, 1, 0, 0. Fine. 1, 1, 0, 0, 1, 0. Fine. 1, 1, 0, 0, 0, 1. 1, 0, 1, 1, 0, 0. So you have to write it firstly and then I will tell you the shortcut tricks. Fine. Now you have to find the dimension of the vector space. It means we have to find basically the rank of this matrix A. And we all know rank is number of the linearly independent vectors or linearly independent rows or the columns. Now firstly, you can think about that. If I add these two columns C2 plus C3 and subtract from here, so this value will becomes my 0, 0, 0. Fine. It is my 6 cross 6. So one column is my 0, so rank can never be a 6. Fine. Now you can think about any of the other pairs. If I look at that, if I how you can make the other values are 0? Is it possible? If I this value, if I add these three columns, because I already used these columns, if I use this value, how I can make this value as a 0? Look at that. Is it possible I can make these values as a 0 or any other way you can think about that? How I make if I take this value as a, so you can see if I add this value, then if I change them, this will be 1, 1, 1. If I use this operation, now you can see if I add these four columns C4, C5 plus C6 and subtract from this second column, what will happen? This value will again a 0. Fine. Now you can see the column is also, rank will not be a 5. Now when it will be the 3? It will be 3 when 3 columns are my 0. Now you can see all are my linearly independent because it has the first one 1 1, these are the two values, but it is there, so the rank of this matrix is my 4 is the right answer, because you will get a 4 cross 4 determinant, which is easily be a determinant is a non-zero. You can see, you can find the 4 cross 4 whose determinant is a non-zero. So that's a right answer of this problem. Okay, now this is the December 2019. W is the dimension of W. Again, how you can think about that? Can you think about in a very simple and a simple manner? You can see these are the elements of the A4. These are the 0. So basically they are my nullity. Fine. So it means you have to find the dimension of the nullity. That's a very simple. Again, I can use the dimension of the subspace M4 minus, this is a condition given to you that Aij is a condition of the K. So count the number of the conditions. That's over. That's a simple shortcut tricks. It's a matrix. What is the dimension of the M4? 16. How many conditions are there? When you take K is equal to 2, I plus J is equal to 2. So 1, 2, 3, 4, 5, 6, 7. So what is the right answer of this? 16 minus 7 is the right answer of this. Because this is my, if you write this as a matrix, definitely it will be the 0. If I write AX is 0, that's a nullity. So you have to write like of this one, rank condition of this. Okay, which of the following two statements are given to you, then which of the following is my correct? Nullity is given to you, rank is given to you. So I always use the rank nullity theorem. So dimension is my M4. 4. Fine. Now it's not a square matrix, M4 is there. Now what is that? Rank is my 2 because it's a basis of the row. Nullity is my 1, which is not equal to 4. First option is cancel out. Column, because rank and columns are same, so it is my 2 plus nullity is my 2, which is 4, is my correct statement. So statement 1 is false, statement 2 is my correct option. Statement 1 is true, false, both the statements are false, both are true. Right option is my A is the right answer. Consider the sequence an of the Fibonacci of this. An is an minus 1, an minus 2. N is greater than equal to 3. I can choose n as a 3. So what is that? A3, A2 plus A1. So if I consider the three vectors A1, A2 and A3, so the dimension will be, so what is that? A1, A2, A2 plus A1. So how many vectors are there? You will get as a 2 vectors. So the dimension will be 2. This is the first method. Second method is, because you have to find the dimension, so we can apply the rank nullity theorem. So rank plus nullity is my dimension. Dimension is my 3 vectors because I consider as n is my 3. So 3. What is the rank of this one single line? 1. So what is the meaning of that? It is my 2. N minus rank is nothing but my dimension of this, because I can write this value as my, so this is nothing but my AX is equal to 0. So we have to find the dimension of just like say nullity dimension, solution space. Okay, A is my n cross n, V is the vector space, consists of all those m cross n matrix such that AX is my 0. So again you can see AX is my 0. So what is the dimension of this V? So as I told you, what is the number of the column vector? N. What is the dimension of this? Nullity of this A. So how you can define that? What is that? What is the A cross is n, column vector is n, rank of this A. Remember this is my A. Now dimension is my A, n, number of the column. Rank of A is my R, n minus R is the right answer. So R is cancelled out, this is cancelled, this is cancelled, this is the right answer. Remember sometimes if he said it is a n cross P, then it will be my, because this is my n cross P, then it will be my P times of this. But right now the D is my correct option of this example. Okay, suppose this is my matrix given to you. Now this is a 3 cross 3, there are the 3 eigenvalues. Which of the following must also be there? One eigenvalue is given to you here. How you can find the 2 eigenvalues? The same tips which I told you earlier. If each row sum is k or each column sum is my k, then k is my one of eigenvalue. So we can see the column wise. Firstly, row wise we can see is a 2, 3, 14, 0. It is not a 0. It's again a 0. It is again a 0. So each row has a 0. So that's a k is my 0. So one eigenvalue is my k. Can the column will be there? So column will not be there. So it is my 26. It is not the same. So what is that? How you can find the third eigenvalue? That is a trace. What is the trace is? 70, 20. So we know sum of the eigenvalues is nothing but my 20. So the other value will be my this. So 20 minus lambda is the right answer of this problem. Okay, A is my 3 cross 3 such that determinant of A and trace is my 0. And okay, that's very simple. So look at the option. Trace is my 0. Some of these are the eigenvalue of A. Trace is not 0. Trace is a 0. Trace is not a 0. Trace is a 0. Trace is a 0. Look at the determinant. Determinant is not a 6. Determinant is a 6 is the right answer. That's over. But if you want to find another method, look at that. A plus I is 0. What is the meaning of that? Minus 1 is the one of the eigenvalue. So minus 1 is the one of the eigenvalue. So this option is again cancelled out. Now trace is my 0. So the 2 eigenvalue, if I say this is my x, it will be my trace will be a 0. So it is my 1 minus x. Fine. That is the only way. Only the trace will be 0. So you can see that this is not satisfied, x and 1 minus x. Only this property will satisfied is the right answer. A is a 5 cross 5 with a trace. So 5 cross 5, it has a 5 eigenvalues. Trace is my 15. So the sum of this will be 15. 2 and 3 are the eigenvalue with algebraic multiplicity is my 2. What is the meaning of that? 2 occurring 2 times. Algebraic multiplicity of 3 is also occurring 2 times. Now we all know that trace. Trace is nothing but by sum of the eigenvalue. So it's a 4. It's a 10. So it is my 5. Then the determinant of this eigenvalue, it is nothing but my product of the eigenvalue. So it is 4, 9, 5. 20 into 9, 1, 8 is the right answer. Look at that. Within a fraction of a second, you can solve the problem in a easy manner. Okay, I is my A cross A square is A. Now in this case, it is given that A is not equal to identity matrix. We usually take A as the identity matrix. So the examiner is very sharp. They consider A as not be here. So what is that? This is my idempotent matrix. So then what are the eigenvalues of this? 0, 1. But I already told you the shortcut tips for you. Whenever there is an idempotent matrix, trace of A is nothing but my rank of A. Also, I told you that trace of the I minus A is same as that of the rank of I minus A. So the first, which of the following is false? This is my true statement. Look at the first, clearly say eigenvalue of A are each equal to 1. That's a false statement because the eigenvalues are my 0 and 1. So this is my correct option. But how you can think about that? Look at that. Eigenvalues are my 0, 1. A has eigenvalue 0, 1. Eigenvalue of the I is my 1, 1. What is the eigenvalue of the I minus A? 1 minus 0, 1, 1 minus 0 here. What is the eigenvalue of the square? 1 minus 1, 0. Eigenvalue of the I minus A, 1, 0. Eigenvalues are same. Both the eigenvalues are same. It means the determinant is same, trace is same, characteristics polynomial same, minimal polynomial same. So matrix feature is also same. This is my true statement, but we need a false statement. Again, this is same because what is the rank of this? One eigenvalue is 0, rank will be my 1. Rank of the I minus A. rank of the I minus A is again 1 eigenvalue is 0, 1. So 1 plus 1, 2 it will be, because I consider the 2 eigenvalues, the 2 cross 2. So it is my 1 plus 1 is my 2, that's satisfied. So both are my correct options. I consider 2 as a 2, otherwise 0, 1 is only 2 cross 2 matrix. So the rest 3 options are correct, only the 4th option is the wrong option. Okay, A and is there. What the usually student will do, student will find the A square firstly in the examination, then we'll check about the A4 and so on, but that is a very lengthy procedure. You can always find the eigenvalue. What is the eigenvalue? I can write the trace equation. This is not the diagonal matrix, so here plus determinant of A. So what is that? This is minus plus 1 still. Fine, these are my trace is my 1, determinant is there. Now look at that, A raised to power n. These are my omega. If I multiply this by here, what will happen? What will happen? This is lambda cube is A cube minus B cube. So what is the meaning of that? Is it true? No. This is a negative sign, so you have to multiply with the plus sign. So lambda plus 1. So it is my A cube plus 1. A cube plus B cube. So this is my minus 1. But we need a plus I. So I can scare them. So it means 6 is the right. So look at that. If you think about here, then you have to do like of this one. A cube. A6 means either you can find firstly A cube, then multiply by A square. Otherwise A square, A square, A square. It will take a lot of the time. Now you can see that is a very simple with the help of eigenvalue. My always advice to the students that whenever there is a matrix given to you, then first preference is always given to you the eigenvalue problem. Think about the eigenvalues and then look about the options. Look at the next one. Again, this is the matrix, so we will think about the eigenvalue. A is the real symmetric matrix. So what are the eigenvalues of the A? It is my real. Fine. It can be positive, it can be negative, it can be 0. It can be positive, less than 0, or it may be 0. So I assume A's eigenvalue is my lambda. What is the eigenvalue of the B? B, it is 1 plus iota of this. Fine. So A is invertible. What is the meaning of the invertible is? So we all know eigenvalues of the complex number always occur in the pair. So what is the invertible? Determinant will be non-zero. So that means what is the determinant of this? That is fine. It is satisfied. Does it implies that A is invertible? It means lambda is non-zero? That is not true, because you can see lambda is a real number. If I assume lambda is my 0, still determinant of B is my non-zero. But because of if and only if is not the right answer. All the eigenvalues of the B are necessarily real. That is it true? What are the eigenvalues of the B? 1 plus here. Now you can see what is that? Lambda is my real number. So what is that? This is my always be a complex number. Is it necessary real? Cancel out. B minus I is necessary invertible. What is the eigenvalue of the B is my here? What is the eigenvalue of the B minus I? So, iota lambda. It is necessary invertible. Invertible means determinant is my non-zero, but that is not true. If I say lambda is my real, if I consider here, what is the eigenvalue of the B minus I? 0, which does not satisfy here. So this option is cancelled. B is necessary invertible. What is the eigenvalue of the B is? 1 plus iota here. So even if lambda is my 0, still B has the eigenvalue 1, which is my non-zero is the right answer. Because first 3 options cancel out, the correct option is my remaining. Okay, how you can find the A20? Student may think about that. Student can find the A square, then you can find the A raised to power 10, A raised to power 4, and so on. I already told you, whenever there is a matrix, think about the eigenvalue. How you can find the eigenvalue? Again, I can think same rule. If each row sum is k, or each column sum is my k, then k is one of the eigenvalue. So it's a 5, not true. 1, 1. So it means one eigenvalue is my 1. So that is a row sum. Fine. So what is the other eigenvalue? So you can see that trace is my 2, so other eigenvalue is also be 1. So this is a row sum. Look at that. What is the eigenvalue of the A20? Again 1 raised to power 20 is 1. So this is the column corresponding to the row sum. So look at that. Is that row sum is 1? Not 1. So this is the option cancel. 1 not cancel. 1 1. Fine. Not cancel. So only the left option is there. So this is there because one of the eigenvalue is 1. Trace 2. So it is 1. So remember, it is a column sum is 1. But you can never say, because A raised to power 20 I computed from using this value, and this matrix, this eigenvalue is obtained by using the row sum. So this value must be from the row sum. If you look about the column sum, then it is a 1. Then it may be the right answer, but remember of the ordering pair. Again, this is a matrix. We will look about this as an eigenvalue. So forget about this 20. What is the eigenvalue of this matrix? This is a diagonal matrix. So eigenvalues are my 2, 2 and 3. Then what is the eigenvalue of the A raised to power 20? 2 raised to power 20, 2 raised to power 20, 3 raised to power 20. Find that trace. So you have to add them. So 2 into 2 raised to power 20, 3 raised to power 20 is the right answer. You can say within a fraction of second you can solve the problem. Okay, A, B, C are the real matrix such that this is there. 3 cross 3 positive matrix, eigenvalues are here. Look at that. This is a symmetric matrix. So whenever you are working on the symmetric matrix, you always look about the quadratic form. So what is a symmetric matrix? Whenever it's a symmetric matrix, all the eigenvalues are my greater than or equal to 0. So first condition, all these diagonal values, all these diagonal entries are my greater than or equal to 0. So it means A must be my greater than or equal to 0. Fine. Now look at that. Second is, all those principal minors are my greater than 0. So what is the principal minor? First principal minor is my first value 1, satisfied. Second principal minor is 2 cross 2 determinant A minus B square. So you can see A minus B square, A is greater than of this. So A minus B square is greater than C square is always be greater than 0. So it is greater than or equal to 0. Look at the 3 cross 3. So if I determinate A minus of B, it will be B, plus of C, it is my 0 minus AC. So it is A minus BC minus AC square. So you can see I can write as A 1 minus C square minus B square. So look at that. 1 is greater than C square plus B square. So 1 minus C square is greater than B square. A is my positive number. So what is that? If I multiply this by here, it is greater than of AB square. So this number is greater than or equal to AB square minus B square. A minus 1 is B square. A is less than 1, but A is my greater than 0. So this number is it always be positive? Is it always positive? No. Why? Okay, I can think about it here because this is from the A. So A is greater than of the B square plus C square. So A minus B square is greater than of the C square. So this is greater than C square minus AC square. So C square is common. Now you can see 1 minus A is greater than 0. It is greater than. So this is the, all the principal values are here. So all the eigenvalues are my positive real eigenvalues. This is my correct option. So this also happens, but we have to exist some pair. There is some calculation mistake. You can check it and let me know your answer in the comment box, but this is the right method. Okay, now this is the quadratic form. Is it symmetric? Yes, it is a symmetric. Fine. Now you can see Q has a rank. This is the quadratic. So the rank of the Q and the rank of A are same always. Clearly say that there are the 4 non-zero eigenvalues. So the determinant of Q, or you can see the determinant of A, is my non-zero, so the rank of the A is my 4. Now this is the quadratic form, so you can write this as a matrix x y z. It's a 3 cross 3. Now there are 4 cross 4, so x y z. So x y, what is that? Z is, if I say x y z w, so 1 0 0. X y, this is my x y. I can take half of this, half of this. Now you can see what is the rank of this. What is the rank of this matrix? There are the 3 non-zero elements, so the rank of this matrix is my 3, but the rank of this Q is my 4. This is cancelled. Look at this another pair, YZ. So YZW. XY. This is my XY. This is my XY. Rest all the values are my 0. Now what is the rank of this? Rank is my 3. Rank is my 4, which is cancelled. Look at the last pair, XY. This XY, ZW. So ZW. Rest all the values are my 0. Half of this coefficient. Now you can see the rank of this is my 4. So there is only left option is there. So rank is 4, rank is 4. Both are same. So they are same. Now again the matrix, we can find the eigenvalues. If you want to find the eigenvalue, that's also the very good option. But this is my symmetric. So then it's a positive definite, negative definite here. What is the meaning of the positive definites? All those eigenvalues are positive, or the principal minors are always greater than 0. First principal minor 3 greater than 0. All the diagonal entries are positive, that's satisfied. Second principal minor is 6 minus 1 is greater than 0, satisfied. Third, you can find the determinant. 6 minus 1 plus 1 minus 3. So it's a 5 3 15 minus 3 is a greater than 0. All those principal minor greater than 0, it means all eigenvalues are my greater than 0 is a positive definite is the right answer. Otherwise you can find the eigenvalues. You can see whether it's a column sum 2 0, column sum are not same, 2 not same, column sums are not same, you can't use this shortcut tricks here. Okay, now this is my inner product space. Again a very simple, look at that. This, what is that? This is my quadratic form. So irrespective of the inner product space, we can think about the quadratic. Now what is that? This is symmetric. This hold only when your this matrix is my symmetric. Is it so? Is it symmetric? No. So first option is cancelled. Dot product, that is phi of v comma w is my 0. What is the meaning of that? This is my 0. Fine. It happens only when your determinant of a will be 0. Is it true? 3 minus 8, which is non-zero. This option is also cancelled. Now there exists a 2 cross 2 matrix, so that you can transform this matrix to the B, which is a symmetric. Can you construct that? Yes, you can always construct. How? You can take the, you can preserve the diagonals, and this the xy, take the average of this. 4 plus 2 6 3. Now you can see it's a symmetric, it's a correct option. If you have say 1 3 3 1 4 3 9 minus 1 say 0, you can convert into the symmetric matrix by using this orthogonal property. Preserve the diagonals. This is the xy, take the average 2 and 2. This is xz, this is my z, this is xz, take the average of this 7 by 2, 7 by 2, take the average of this minus half, minus half. You can see this is symmetric, which satisfied this property here. Look at the last option. Again, this is only one correct option, so the last option is cancelled. But how it is not a linear? We all know the linear property said this must be of this nature. It is not satisfied, because if I take alpha times of this, it will be alpha. If I substitute here, it will be alpha square, but we need a alpha, so this option is cancelled. Okay, now again look at that. This is a quadratic form. Okay, you can compare them coefficients. You can compare the coefficient. This is a square plus c square, x square. so it is a greater than equal to 0. This is cancelled, this is cancelled. Fine. Now how it's a greater than or not? Look at that. This value is always be positive, so this is a quadratic, so I can use the quadratic formula for here. So I can write this as quadratic nature. How you can write? As I told you here, you can take the average of this x and y. So this is preserve the x and x here, take off this, half of this. So what is that? It's a positive definite because it's a greater than equal to 0 always. The right hand side is always greater than 0. So positive definites, all the eigenvalues are my greater than 0. So the first principal minor here, second principal minor this. So what is the meaning of that? So this is a relation, this is a relation. From these two relations we can find that it is greater than equal to 1 is the right answer. Okay, look at this next one. This is the inner product space, and here this is the orthonormal. You all knows what is the orthonormal property. If I say u and v are orthonormal, what is that? U square is my 1, v square is my 1, dot product will be 0. Fine. So now from here, first pair is satisfied. This is a 1. U square is 1 satisfied. Now look at this option. If I start from here, if I take, what is that? If I write in the inner product space, it's a v comma v. So firstly x comma x, it's a x square. Clearly say that it's a 1 over 3 which is not 1. Cancel out. X root 3. X root 3, x root 3 is a this into this. So what is that? It's a 3 outside, x square, x cube by 3 from 0 to 1. It is 1. X square, x cube by 3, 1. It may satisfy. Now, third property, 2x minus 1. So 2x minus 1 square of root 3 into 3 is a 3. So if you integrate them, it will be 3 over 3, 2x minus 1 square over 2 from 0 to 1. If we substitute 1, it's a half, minus, it will be, when you substitute here, it will be 0. Sorry, it's my mistake. It's orthogonal, it's an inner product space. So orthonormal means perpendicular. You have to prove it must be the 0. So it is not 0, cancel out. It is not 0, it is a cancel out. It is a 0, it may be the right answer, but if we check about the last option also. So x minus half, it's a square from 0 to 1. So this is x minus half cube over 3, 0 to 1. 1 is a 1, half cube by 3, and minus half cube by 3. It's not a 0. So this option is cancelled. Only the right option is my C is the right answer. Okay, which of the following is my inner product space and here? That's very simple. How you can do that? You can apply the inner product space property. F, G scale. Fine. What is that? F and G are the any mapping. That's simple. If I consider F is my minus of G, what is that? It's a minus G cube. Fine. If I consider F of T is my minus of T, G of T is my T. All are my continuously differentiable function. So what is that? This is my minus T cube. The integration is my 1 by 4, which is less than 0, but inner product space is always be greater than 0. So this is cancel out. F comma F, I consider F and F both are same. It is cancel out. Is it bilinear? What is the meaning of the bilinear is? If I take as G plus H, it must be of Fg and F of H. So look at the left hand side. This is G plus H square. And look at the right hand side, it's a Fg square, and this is Fh square. Clearly say that when you open this bracket, it is Fg square plus 2 times of this, but this term will always not be 0. So this is not true. It is not a bilinear. Correct option. This is the wrong option. Okay, this is a 4 cross 4. A has eigenvalue this. How you can open that? trace of A, trace of B. What is the trace of A? Minus 1. How you can find the trace of B? Eigenvalue of A is my minus 1. So 1 minus 5 plus 5 is 1. When it's a plus 1, 1 minus 5 plus 5, 1. Third value is again 1. Corresponding to the minus 2, 16. It's a 2, 5 into 4, 20 plus 5. It's a 1. So the trace will be 4. Eigenvalue is my 3 is the right answer. And once you know the eigenvalue of the B, these are the eigenvalues of the B, these are the eigenvalues of the A. If somebody asks you find the determinant of A into B, you can find the eigenvalues of the AB. You can find the determinant of A plus B, find the eigenvalues of the A plus B, that is the sum of this, and find their product. Okay, which of the, this is already I covered that. How you can say that eigenvalue of the A must be less than of the number of the column vector, that is you have to find the determinant of them as a 0, you will get S. I already explained you in the previous questions. Okay, unique solution, no solution are here. Very simple. You can see I have to write this in terms of the A argumentative matrix, and my target is to make this diagonal entries are my non-zeros. Say A, this is something, and these are my 0, and this is my something. This is my target. These are any value are fine. Now there is first method is there is no need to solve. Just think about that. This is your target. Now when it will be the no solution? No solution means when rank of A is not equal to the rank of A condition B. Fine. This is my A. This is A condition B. He said when this like of this, I can write this number as of this number as say alpha, because this is in terms of the alpha minus something, and this is beta minus something. Fine. Now look at that. No solution means rank are not same. If he said beta is not equal to something, beta is not 7, there is no restriction on the alpha. So what is the rank of the this? This is 3. If this value is not equal to 7, then what will be the rank of the A condition B? It still be 3, because it still has a one pivot element, but in that case it will not be a no solution. So this option is cancelled. When it will be the infinite solution? When these both are same and it must be less than of the number of the column vectors. So column vectors are my 3, less than 3. When it has my rank 2, it has my rank 2. When it will be have rank 2? When this number must be 0. That means this number must be equality sign, and this number is also be equality sign, but he said not equality. So this option is cancelled. Infinite number of solution, when alpha is equal to 2, that's fine, equality satisfied, but beta will also know as a equality, but he said not equality. So this option is also cancelled. So there is only one option. How you can say the unique solution? Determinant will be non-zero. So you can see what is the determinant of, there is no need to solve, but if you want to solve, so alpha minus 3 plus 1, alpha minus 2 plus 1, 3 minus of 2 is my non-zero. So it is alpha minus 3, 2 alpha minus of 2 plus 1. So what is that? 2 alpha minus 4 is my non-zero, alpha is my non-zero. Otherwise you can simply, I again recall you must be very strong on your theory conceptual subjects. Again you have to find the system. You can write this as 1 2 1, 2 1 minus 1, 3 3 0, 0 1 1, and this is my 6 5 7. Fine. So what is that? Rank of A is my column is my 4. So rank of A will definitely be the 3. Rank of A by B will definitely, whatever is there, it is less than of the 4. Number of 4 is my number of the column vector. What is the meaning of that? It has no solution. Why? Because you can see, no sorry, it's an infinite solution, but we can see if I subtract them, it's a 0, it's my 3, it's my minus 3, it's my 1, it is my plus 1. If I multiply 2 and then 0, multiply 2 is a 3, multiply 2 is a minus 3, 0, it's a 6, 12 is my minus 7. Now you can see, if I simply subtract them, it will be my 0, it will be my 0, it will be my 0, it is my 8. So the rank of the A is my 2, rank of the A condition B is my 3, both are not same, it has no solution, rest options are cancel out, right answer is my B, last option. Okay, this has a solution or not. So right hand side is there. We can firstly check about the uniqueness. Find the determinant of this. If it is non-zero, what is that? Rank of A is my 3, number of the columns, and it must be same as that of here. So we will get as a unique solution. So determinant of this, 2 minus here, minus 0 plus 5, 5 plus 2. Clearly say that it is non-zero. It is minus 26 plus 35 is my non-zero. So it will give you a unique solution. So once it's a unique solution, rank of A condition B, and is a number of the column is true. So it means whatever the solution of y, it is for all the pairs of the y is my right answer. Which of the following is my consistent? Consistent means either the unique solution or infinite solution. Fine. Now it's a number of the columns are my 2. So my target is to find the rank of A, either is it 2 or less than 2 or less than 2. So that's a very simple. Again, firstly I can take, say, k is equal to 2. If I substitute here, it's a 2x plus 2y 0. Second is 2x plus 2y is equal to 2. Is it possible? It is not possible. So that's a no solution. No solution means inconsistent. So this option is cancelled out. I can check for the minus 2. 2x minus 2y is equal to 4. 2x minus 2x plus 2y is equal to minus 2. Again, it is not satisfied, because you can see if I subtract from the negative, it will be the plus of 2, not satisfied, is a cancel. When you take k is equal to 1, then it's a 2x plus y is equal to 1, x plus 2y is equal to 1, y plus z is equal to 0. Now from these two equations, once you will solve, there is no need to solve, just think about the conceptual. You will get a unique value of the y, you will get a unique value of the x, because the determinant is 4 minus 1 is a non-zero. You will get a unique x and unique y. Once you get a unique y, you will get as a unique z. So it means you will get a unique solution. Correct option. Check about the minus 1, sorry. So 2x minus y is equal to 3, minus x plus 2y is equal to minus 1, minus y minus z is equal to minus of 2. Again, determinant is 4 minus 1, 3. You will get as a unique x, unique y. Once you get a unique y, you will get as a unique z. So this is also the correct option. Okay, C n is my n cross 3, so I can simply take n is my 2. 1 is the only eigenvalue. So this is the example, simple. Fine. So what is the meaning of that? That is A is equal to I. Then T is equal to I. Sorry, this is a T. T is equal to I. So which of the following is true? Clearly cancel out. If I take k is my any natural number, clearly say that t square is my I. T minus I. What is that? T minus I. N minus 1 is here. So what is that? It is 0, 0. But if I consider it as a 1, still eigenvalue is there. This is fine. For the second case, I can consider this value. Eigenvalue is my still 1. So what is that? 0, 0, 0, 1, which is my non-zero, but he said 0. Now, for this case, 1 is the only eigenvalue. So what is the t minus I? That is simple. If I say lambda is my eigenvalue is only 1, it means what is the characteristics equation? A minus I of, or you can say this is my here, or in general it is my n. So what is the characteristics equation is my here. Fine. So this is satisfied. Now it's n plus 1. So I can return this number as of this into t minus I. This value will be 0. So this value is also 0. So both the options are my correct options. Okay, now you can see here I can think about the pair of this. It is 1 over 2n 3n, n varies from 1 to infinity, plus for the second case I can take the pair of n plus 1 3n, n varies from 1 to infinity. So what is that? This is 1 of 6 of n. This is a GP, so GP sum is here. I can take half as a common, then it is again a 6n. Again it is my GP, 1 minus 1 by 6. So what is the right answer? It is 1 over 5 plus 1 over 2 into 1 over 5. So 3 over 2 into 1 over 5. So 3 by 10 is the right answer. Okay, look at this next one. So which is given to you as here. A is my orthonormal basis, inner product V1 Vn. So firstly I can take n is my 2. So then it is my V1 and V2, which is my orthonormal basis. And A is my matrix formed by such V1 and V2. What is the meaning of that? Once they are the orthonormal basis, this matrix is my orthogonal. So once this is my orthogonal, what is the meaning of that? A into A transpose is my I. A into A transpose is my I. So you can clearly say that this value, if I say this is my here, this is my orthogonal, so clearly says the determinant is not a 1, this option is cancelled. Inverse you can take the another examples, but this is the only right answer of this part. Okay, which of the following is there? Theta is my unique real number, here then theta will be here. We all know I can return this number as of this. Is a differentiable. So we will check about the parts. It's a 2 variable, y is equal to mx. So tan inverse m, which is not unique. So it means limit does not exist. It means it is not continuous. Once it's a not continuous, it means it is not a differentiable. So first option is differentiable, not a continuous, bounded, neither bounded. How you can check the bounded? We can start from here. Tan inverse y by x. What is the upper limit of the tan inverse? Pi by 2. So we can see it's a bounded. It's a bounded, not continuous, neither bounded, cancel. Right option is third is the correct answer. Okay, look at this another one. So this is square root. I can rationalize them. You can see if I rationalize them, it will be root 2 minus root 4 over minus 2. Look at the second pair. It is root 4 minus root 6 over minus 2. Look at the last pair. It's a 2n plus 2 over minus 2. Now if you add them, because it's a sign of the plus sign, if you add them, minus 2 will be LCM, it will be cancel out, it will be cancel out, it will be cancel out. So the remaining part is first term and the last term divided by minus 2, and 1 root n will be here. Then take n approaches infinity. If I take the first part, it will be root 2 by this part, it goes to the 0. Another part is minus minus plus 1 by root 2 of 2n plus 2 over n. So this part will goes to my root 2. So what is that? 1 by root 2 is the right answer of this part. Okay, P is my 2 cross 2 invertible matrix such that P star P is my identity. P star is a conjugate transpose. What is that? I think what kind of the matrix is formed here? This is nothing but my unitary matrix, or what I think what we called as, is it a unitary or what we call this as? We all know the eigenvalue of this is my plus minus 1. This is a unitary matrix. Yes, this is the unitary matrix. So what is the eigenvalues of the unitary matrix? It is always be a plus minus 1, that is a modulus 1. So this is all about all these questions. So I hope you can simply learn the various shortcut tricks. Remember that whenever you are trying to solve the linear algebra questions, whenever you see the matrix, think first option by eigenvalue. Then the problem will be very easy. And whenever there is a n cross n, you can think about that 2 cross 2, 3 cross 3 as per your own convenience. So I hope you can simply learn the various shortcut tricks. We will see the next part on this part C question where more than one correct options are correct. I hope you can simply like, share and comment on my videos. Best of luck students. Happy learning.